Previously, we've been given a line and asked to write the equation. We're going to use those same skills to be given an equation and asked to graph the line. Let's go ahead and look at these directions at the top. So when you are graphing a line, you will be given the equation of the line in y equals mx plus b, or slope-intercept form. From that y equals mx plus b form, you will first plot the y-intercept, which is obtained from the start value of the equation. So the y-intercept will be plotted on the y-axis. Every point on the y-axis has an x value of 0. And then you'll find the y-coordinate from the start value. From that y-intercept, you will then plot additional points using rise over run, either going up for a positive rate of change, positive rise, or down for a negative rate of change or slope, negative rise. You will obtain that rate of change from the m. If that m is a whole number, the run will be 1. Importantly, in algebra, the expectation is that you will work backwards, plotting every single point that is possible on the grid to both edges of the graph. Let's go ahead and look at our first example, our first equation, y equals 2x minus 4. So the first thing that we do in these directions is we plot the y-intercept. So the y-intercept is obtained from the start value, y equals 2x minus 4. That means the start value is negative 4. That means the y-coordinate of the y-intercept is negative 4. It is very important that the start value is always graphed on the y-axis. A few students tend to get confused and plot it on the x-axis. The start value is the y value when x is 0. It's on the y-axis. So for this particular graph, my y-coordinate of my y-intercept is negative 4. So 0, negative 4, my first point. Then I am going to write my slope, which is 2. Oops. My slope, which is 2, as rise over run. So since that is a whole number, 2 gives me my rise, and my run is just 1. This is because my rate of change, or my slope, is how much y goes up or down when x goes up by 1. So my rise, how much x goes up or down when x goes up by 1, that is a run of 1. So from my y-intercept, rise of 2, up 2, and then a run of 1 over 1. Rise of 2, up 2, over 1. Rise of 2, up 2, over 1. And then just continuing that pattern to plot every single point on the right-hand side of the coordinate grid. When we work backwards, you may just be able to visually continue the pattern, or you may need to think instead of up to right 1, we go down to left 1. The expectation is that we will connect these with a straight edge. Let's see if I can figure that out on here. Oh, that's a pretty good straight edge. And then I also need to make sure that I include arrows. So a straight edge, that doesn't have to be a ruler, just some sort of object that allows you to draw a straight line, and then including arrows, because this equation represents an infinite pairing of x and y, goes forever to the right, forever to positive infinity, forever to negative infinity. That is my first example. Let's go ahead and move on to the second example. Y equals 1/2 x plus 3. So here again, I will obtain b from my equation, my start value of 3. That means the y-coordinate of my y-intercept is 3. I plot that point on the y-axis. X is 0 for every point on the y-axis, and then my start value gives me the y value. So when x is 0, y is 3. X is 0, y is 3. When my slope is given as a fraction, this is actually a little easier. My rise is my numerator. My run is my denominator. That means my change in y is 1, my change in x is 2. When y goes up by 1, x goes up by 2. Up 1 over 2, up 1 over 2. Using my understanding of rate of change, this means when x goes up by 1, y goes up by a half. That's true. When x goes up by 1, y goes up by a half. But we're not going to plot fractional coordinates. So instead of over 1 up a half, over 1 up a half, we're going to use the idea of rise over run to only plot precise points that are directly on the grid. Up 1 over 2, up 1 over 2. Working backwards, you may just be able to visually continue the pattern, or instead of up 1, right 2, we go down 1, left 2, down 1, left 2, down 1, left 2. Connecting those points with a straight edge, and of course not forgetting arrows. If we didn't include those arrows, that would mean that this was a line segment that only existed for x and y values in this particular visual region, but that's not true. There is an x and y pairing for every value of x up to infinity and negative infinity. So when x is 100, y is 53, and that exists. Next example, y equals negative 3x plus 1. So this is our first example with a negative rate of change, negative slope. First, however, let's go ahead and identify that start value. So b is 1. B is 1 means the y coordinate of the y-intercept is 1. We start at 1 on the y-axis. Starting at 1 meaning y is 1 when x is 0. When I have a negative slope, again, slope is just our graph word for rate of change. When I have a negative slope, I give that a negative rise. I always want to think of a positive run because when x is increasing, y is going down by 3. So run. So negative rise, we're going to start with that, down 1, 2, 3 over 1. Negative rise, down 1, 2, 3, and x increases by 1. Using our understanding of rate of change, look, when x goes up by 1, y goes down by 3. But generally, instead of going over 1, down 3, we want to think of rise first, just so we make sure we don't make any mistakes. Down 1, 2, 3 over 1. Continuing the pattern, up 3, backwards 1. Up 3, left 1. It would work if we made that negative 3 be positive rise of 3, run of 1. So up 1, 2, 3, backwards 1. So if instead of negative 3 over 1, we did 3 over negative 1, up 1, 2, 3, backwards 1, that works. It's just, I don't know, the convention that we make the rise negative. You want to make sure, though, whichever one that you are using, that when you look at your graph, hey, I have a negative slope, and so I need to have a downward sloping line. As x gets bigger, as I move from left to right, x getting bigger, y is getting smaller. Straight edge and arrows. My last graph, my graph of y equals negative, y equals negative 2/3 x. The difference here is that I have an invisible start value. My invisible start value is 0. So if there's no start value given, that means the start value is 0. That means I start when x is 0 at y equals 0. The line will go through the origin. That's the point 0, 0. Again, so now I have my negative in front of my fraction. It's still suggested that we stick that negative with the 2. So let's go ahead and write a negative rise of 2 and a run of 3. Down 2 over 3. Down 2 over 3. We could instead put the negative with the run, so up to backwards 3, and that actually helps me plot my backwards points. Up to backwards 3, that's fine. But the expectation, or what we need to check, is that since I have a negative slope, as x gets bigger, y gets smaller. Connecting those points with a straight edge and never forgetting arrows. Checking my understanding of rate of change, when x goes up by 1, y should go down by 2/3. X goes up by 1, y goes down by 2/3. That's just really difficult to verify with fractional rates of change. Can you tell visually that when x goes up by 1, y goes down by 2/3? I can't. I would not be able to precisely graph x going up by 1, y going down by 2/3. And that's why we use these whole numbers down to over 3. So instead of when x goes up by 1, y goes down by 2/3, we do when x goes up by 3, y goes down by 2. So over 3 down 2, or down 2 over 3.